All right, everyone, welcome to another episode of the TWiML AI podcast. I am your host, Sam Charrington, and today I'm joined by Rob Walker, VP of Decisioning and Analytics and General Manager of One-to-One Customer Engagement at Pegasystems. Before we get going, be sure to take a moment to hit that subscribe button wherever you're listening to today's show. Rob, it's been almost 3 years to the day since the last time we spoke. Welcome back to the podcast.
Yeah, thank you. Yeah, glad to be here. Incredible. 3 years ago. My God.
It has been a crazy 3 years. Why don't we have you introduce yourself or reintroduce yourself to our audience? It's been a while. Tell us how you got involved in AI, and we'll jump in from there.
Yeah, no, happy to do that. Yeah, well, AI is, has been a real passion of me for a long time. I'm not prepared to admit how long it is, but I did a PhD in AI a long time ago. Before it was really fashionable, I was just very intrigued by the promise. But obviously at that point, it was. Well, we had neural networks, not the deep learning quite yet, but definitely the learning. But it was also, expert systems and rules. But that got me really into that space. So I did my PhD, then worked for a large consultancy firm around mostly predictive analytics, what we probably would now call data science and consultancy around that. And then really wanted to set up my own company in an area called decisioning, which was not quite a verb, is not quite a verb, I think. So maybe we coined it, but it's pretty popular right now. And that sort of is like an applied way of of using data science and predictive models. So I've always been intrigued by sort of apart from the science of it, but also how to make it like really practical. So that company I sold, and then through another acquisition, got to be part of Pega, where I'm responsible for that part of the business. So basically, long-winded way of saying I've never done anything else than sort of AI, and then applied AI. So yeah, I'm always excited to talk about that.
Awesome. Well, let's talk a little bit more about the use of AI and ML in the context of customer engagement and customer decisioning. What are the types of problems that you find yourself helping people solve?
Yeah, and this is actually sort of even way back. I've always tried, maybe that's the consultancy background. I've always been very careful, I think, to align this with outcomes, because AI and machine learning is obviously huge and very broad. Even in customer engagement, it's still relatively broad, because it can go from creating auto-generating text or images that you may want to use in marketing to stuff that we do, which is really around determining the next best action or the next best experience, next best conversation. There's a lot of next best now in the market, but have AI in combination with business rules determine what you should be talking about with a particular customer to make that super relevant and very contextual. So the business outcomes are usually around mutual value creation, right? So it's obviously can be about revenue, but in these times, during the pandemic, actually especially, but also in other sort of economic downturns, it's also about maybe coaching or counseling customers, towards financial resilience. It's really not just about selling. Next best action is really about, like, across the whole customer life cycle, whether it's nurturing, retention, risk management, sales, or actually determining in real time that nothing is really relevant enough, so we shouldn't steal the moment from the customer to talk about something. But it's really about so where the machine learning and AI comes in is in part to determine what's best in next best action, right? So that metric, because that sounds very simple, but in practice it means that if you combine that to another big thing that's really important to our vision, is the sort of the one-to-one approach, right? So it's not working off averages and segments, but it is really like, for this particular customer, Sam Charrington is calling or browsing or swiping on his mobile app. Now, what do we do based on what we know about him, based on what he's currently doing, maybe what he's even doing in other, on other devices or other systems? What should we be really talking about? And then the moment you do something and react to it, we need to, recalculate that in the moment. And the relevance, I think, is a key thing. And that's where we use the AI for. Like, what are you likely, going to be favorably disposed to, or what is top of mind for you?
Yeah. Yeah. How do you distinguish this idea of next best action and determining it from a recommender system, which we're all familiar with and interact with all the time, but both from a kind of higher level use case perspective as well as from a technical perspective?
It's interesting because the
Is it just
a recommended.
semantics, or is there some meaty distinction there?
No, there is a meaty distinction because we actually work in a few, in some e-customer or e-commerce clients where both are being used, right?
Mm,
And typically, I mean, in next best action is really at a customer level, right? Whereas the recommender system is an input to that on, doing a basket analysis and those kind of things, and then saying, hey, people like you have bought this based on transactions, and that's only part of it, right? Because, for instance, the next best action would, on top of that recommendation, say, yeah, that's really, what that person would be interested in, what that customer is interested in, but it's too expensive. Or we believe that if he took out a loan on that, then he wouldn't repay it. Or he is actually not interested in this at all because there's a service issue that we should really solve. And that's what, is actually the most pressing thing right now. So it's an input to a next best action. And it's an insight that is useful, but can easily be overruled or augmented by, other more important insights.
got it. So what I'm hearing there is that recommender systems tend to be kind of broader, maybe product and offering based, and this idea of next best action is very personalized to the individual.
Yeah, and very personalized to the individual, and I think that is sort of, I think, the important thing, and also looks at a lot of different things. As an example, right, the recommender system might say, hey, this is like, your 4K television that you would likely be interested in because people like you would have bought that, right? But then on top of that, you would really have to look at, like, can you afford it? Did you already maybe, buy that particular television? You already have it, so you may be interested because you already actually bought it, and we should do something else, maybe an accessory to that television. There is, like, all of these things come into consideration. So to us, it's just one of the many propensities you would get, product propensities. That's the outcome. And in the case where we work with, like, retailers, actually next best action is often used sort of at the category level. So it's using, hey, like, hey, we have this person, we think based on everything she's been doing, this is the category she's interested in, which may be, high definition televisions. And then which particular brand and model of television might be the output of a recommender system. and,
Mm.
and and technically, because you also asked technically, the other thing is that the recommender system doesn't really have to, refresh all the time, right? So in these scenarios where, next best action works with the recommender system, it's fine to, overnight churn and create 10 million different probabilities at the product level, at the SKU level, right? Whereas next best action will just grab that from the database, but then adds all the contextual insights and behavioral insight to decide, yeah, this is the thing we need to actually talk about.
Sounds a little bit like the fusing of a CRM and a recommender, and um, all of the possibilities that are created by machine learning.
It's a great combination, and it is really at the because a recommender system is really at sort of the SKU level recommendation, which in a customer experience, customer engagement context is really only one of the things you should be looking at if you want to be, customer centric.
Got it. Got it. And so if you're building a system like this, what are some of the things that you need to be thinking about from a machine learning perspective to deliver these types of next best actions?
Yes, next best action recommendations. Yes, it's fine. A
Okay.
recommender system is just a particular class, of algorithms that's just an input. It's very confusing. But I think the important thing, and this is obviously an open door, but I just want to sort of say it still, it's not like doing AI or machine learning for, AI's sake, right? So we really start, and I've always started from the business side, right? So what are the outcomes in a customer engagement you want to achieve? Is it revenue growth, or is it revenue growth with like constraints on risk? If you're a bank, you can hand out, as we've seen, a lot of mortgages, but what does your risk profile look like? So you look at sort of the outcomes and KPIs, and once you have established sort of those broad business goals, then you can sort of see the scaffolding of the best metric in next best action, right? And the best then say, if this is the outcome, what kind of thing are we? If, for instance, if this is about retention initially, right, and we want to retain customers that are dear to us and profitable to us, but we see sort of the the bells of churn, and we need to see if we can save them. From that metric, you then have to decide, okay, what kind of rules apply. So that's human judgment, or economic factors and profitability factors, right? Like, hey, if we want to retain you, Sam, right, but how much is that worth to us? What can we actually do that would be that we have in stock, in terms of convince you to stay longer with us, for instance. So that's pass one, and then you're sort of start at the machine learning AI level, where now we need to figure out what is on your mind, right? What you would be interested in, what you would likely say yes to, right? And then one level below that is another level of machine learning and AI, and that is like, okay, once we have decided that we know what to talk to you about right now, right? And that can change on a dime. We'll probably talk about that later when we talk about like real time and those kind of things. But once we've decided this is what we need to talk to you about, now the question is, how are we going to do that? Like, are we using a visual? What's the script? How should we say it? All of these kind of things. And again, that's where AI and machine learning will come up, based on collective learnings, on what's best. That's sort of the approach. Very much top down from the outcomes, and then all the way down from outcomes and KPIs to rules to predictions to the data that is then required to actually make those predictions.
And is that last part relatively new? You mentioned kind of creating the script. Are you now at the point where you're looking at generative AI to kind of assemble this script from a set of data points?
Yeah, we pick actually sort of more script or content, because I think that is a particular use case of AI, which is very interesting. To generate what is the perfect sentence, what's the perfect image. So we do sort of some creative optimization, but it is of a stock, right? Because I think especially generating it, right, not picking the best one, but
Right.
generating it, very interesting. It's not what we do, but we work with systems like that and say, hey, we give you the context, we know exactly what we want to talk about. If you can pick or construct, more interesting, the right background image or the right banner text, then that's great. We don't specifically do that. We just pick it from a library of actions, which can be thousands of things.
A couple of things that you mentioned jumped out at me. One is this idea of starting from the outcome. Another is, prior to that, you mentioned that you use a combination of machine learning and heuristics. I'd love to get your take on kind of how those are coexisting in your engagements nowadays. I think we've kind of, there's been this pendulum swing of, hey, we're going to do everything using statistical machine learning, to, hey, we've got all this domain knowledge and these rule based systems. Can we find ways to fuse them together? I'm curious how this plays out in the types of problems that you're solving.
Yes, and I think it's a very interesting I think topic to discuss a little bit, because the combination of sort of heuristics or even human judgment in most cases, but mostly heuristics on top of machine learning. I think that combination is important for a few reasons. I think one, there are just things that honestly require human policies, at least, right? For instance, an AI will not tell you that, unless that's what it's trying to do, but will not tell you that there is a competitive pressure or there is an announcement of an acquisition in your industry, and you need to really prepare for that and change tack. So that's the kind of heuristic that you really want to change quickly, but you don't necessarily want the AI to do those kind of things for you, and definitely not unsupervised. And that's the second topic, is that in the industries we do most in, which is retail, banking, insurance, communications, healthcare, it's typically very important that you can also, to some degree, and in many cases to a pretty significant degree, explain what is happening, right? So if you had like AI, especially the fancy algorithms, try to figure out everything, that would not be an acceptable way of doing it, even if it worked. But in combination, so the heuristics on top of thousands of insights that are generated by AI and machine learning, we've learned that just from a business outcome perspective, that's pretty, unparalleled performance.
And can you talk a little bit about how you make that work? Is it kind of fusing rules engines with algorithms?
It is, although that makes it sound a little bit like it's like a technical integration. And the thing is, we've done this for a very long time. I mean, we spoke last time 3 years ago, but I've been in this business, as I said, much longer than I care to admit. And we've really been very opinionated now, in a good way. Opinionated sounds maybe a little bad, but it's like, we know sort of what these large brands, or in particular industries, what's best practice, right? So it's really like more of a declarative way of saying, hey, let's take you through this process of defining the outcomes, then defining rules, like for instance eligibility rules, right? I mean, whatever the AI thinks, you cannot actually sell a car to a 4-year-old, right? Even if the person would be really really interested to buy like whatever. There's like all sorts of rules. There may be inventory, there's risk and margin rules, there's all sorts of these kind of rules that you need. So that's what you start to define: outcomes, then eligibility rules, suitability rules, maybe some competitive priorities that you see. And then you start looking at sort of the full action library. So what are all the actions across nurturing and onboarding and selling and retention and risk management, like collections, across all of the actions in those categories. um, how are we going to arbitrate given the top of that pyramid that I just described, right? And then automatically, and automatic is here one of the key words, because there's thousands of these actions, and if you have the treatments on how to present those actions, it gets into even bigger numbers. For each of those, you need a predictive model to predict this is the interest in the moment, right? And it's not like you have to import or something, or find 1,000 algorithms in the organization. The way that typically, because that would obviously be fine, but unmanageable. So the way that really works is that we look at the data science output that's already available, right? They may have a risk model or many risk models or attrition models or propensity models for certain very important products, which we would actually import into that framework so we can execute it. But we almost always complement that with a massive machine learning capability to complement data science, right? So data science, typically with the kind of brands we work with, would still monitor that. So it's like they shouldn't really care whether this is a model they created in um, Python or whatever it is, or it's a self-learning model that Pega has supplied to them. It's their responsibility. but it just gives them much higher throughput, right? Because these models learn on the fly. They look about competitive actions. They look about seasonal influences. Well, all of these kind of things. Um, and just back to your question. So this top-down approach, declarative from the outcomes, then the rules that every business will understand, like eligibility and profitability and all of these kind of things, then to all the actions and their propensity models that are generated automatically. That's sort of, I think the state of play currently in the industry. It's not a patchwork of like costly integration to do this. It's just that's the motion for next best action.
And when you go into a large brand, do those propensity models already typically exist, or are there, are there holes that need to be filled or new ones that need to be created in order to fulfill the framework that you're trying to create?
Yes, two things about that. So usually, so first of all, from a decisioning perspective, that's that verb again. Um, um, we're really trying to be agnostic about where the algorithms comes from, right? Because there's great open source tools. The big cloud platforms will have offer increasingly more analytics. So I don't really care about any of that, where that comes from. I just care about like, can I have an algorithm behind every single action and treatment? And can I execute it in the moment? That's very important. So I don't want to retrieve a probability from a database, right? Because if a customer says no, right, then I want to reevaluate 1,000 different predictive models where that no may have some influence, and then redecide what the next best action is, right? So we usually when I say usually, actually I mean always complement the existing models, the data science models, with this machine learning capability. But one thing I would like to add is that on top of that, and this is I think what a lot of brands are also asking for, is around like this whole responsible AI, right? We also want to make sure that every algorithm, whether the data science department build it or our machine learning generated it for them, um, will have to adhere to sort of the tenets of responsible AI. Like, is it a fair model? Is it a robust model? Is it transparent if you need it to be transparent in a particular asset? Is it empathetic, which is sort of in my mind really about like, is it relevant? But anyway, those tenets of responsible AI are much easier to enforce if you have like a central AI policy that you can apply to your next best action strategy, wherever the algorithm originated from. I think that's important. And lastly, Sam, before we move on, it's also like, because it's this combination of heuristics and AI, we can't just look at an AI algorithm and say, oh, it's biased. Well, if it's biased, and we have a problem. If it's not biased, that doesn't mean that your overall outcome is unbiased. If you apply your rules to it and 100 other models and then arbitrate, is the final outcome of that, the final recommendation, is that fair, right? That's more of sort of the challenge that we take on.
Okay. I want to circle back to responsible AI. One of the things you mentioned in kind of drawing this distinction between data science and machine learning, or these propensity models and kind of the decisioning on top, is that you don't want to have predictions in some database, because you want to be able to evaluate them real time across these thousands of models. Uh, Talk a little bit about the doing that at scale.
Yeah, that's hard. That's actually
It sounds hard.
it is hard. Yes. So I think part of certainly of my career, but also the teams that have been building this, is all about that scale. Can you do that at scale, and can you do it fast enough, right? Because remember, this is customer engagement, right? So it means that if you were saying no to something, we need to, within a fraction of a second, we need to take that no into account, recalculate 1,200 propensities, apply all the rules on top of it, and then say, oh, but in that case, and then have the next best action ready, right? So that's from a technology perspective, I think is quite a feat. And I think it's often confused and maybe even downplayed a little bit in not sort of in the market, like, well, do we really need real time? And there are really two different things. One is like, do we have all the data real time? And that can be a challenge, and you don't need all the data, real time. I don't need to know your birthday in real time. That's fine. But the thing that you are doing in a particular channel, right? What I'm browsing, what I'm clicking, what I'm not clicking, my mood, all of these things that we can now figure out increasingly accurately, all change the context, right? And I want to have the most up to date, really up to the second context added to sort of a more static profile, and then apply all of these algorithms to it, right? If I don't, then if you said no, then the results would be pretty much the same. Well, I would probably suppress it in a rule. I would say, oh, if he said no, well, let's not offer this again in 3 weeks, right? But in fact, your no informs 1,000 predictions, right? That again, maybe some of them will not change. A lot of them may change a little bit. Some may change a lot, right? And then the next best action, that kind of relevance is, I think, that's sort of definitely our claim to fame. But relevance drives conversions, drives customer satisfaction, drives a conversation like interaction. And that's why it's important to not retrieve a score from a database that is, even if it's a minute old, that's already not great. Like, it would be like we would be talking with like a minute delay. It would be hard. Yes, it's the way it usually works. So first of all, we do support both on-premise and cloud model, but pretty much all we do is it's all cloud, either our cloud or the client's cloud, the private, whatever. All of these options exist, and it's actually more of a data and data governance challenge than it is a technical challenge. But what we do is, like, we do pre-aggregate all the things we can pre-aggregate, and again, that's completely automated, right? There's no building. It all comes from declaring what your business challenge is that you're trying to solve, from that pyramid that I described, from the outcome down. But also all the data transformations, are also happening in real time. But for instance, what we don't need to calculate in real time is, like, for instance, if you are, with like, a telecom operator, right? We don't need to recalculate your text messaging or IM volumes over the month. Is that going up? Is that going down? Those kind of things you can, if that's a material predictor, right? You can pre-calculate all of that. And there are many of these kind of trending things that we would sort of pre-aggregate to make sure that in the moment we don't have to do that, and we can just take your monthly average and your weekly average and your 3 monthly average as pre-calculated, assuming that.
Hmm. In the machine learning and ML ops ecosystem, there's this notion of a feature store, which sounds a little bit like what you're describing. Do you relate this this idea to a feature store?
Yes, I would definitely call it that. We call it an extended analytics record, but that's pretty much the same thing. So it's the usual profile data, then as much of a transactional data that you have, or that the brand cares to share. Could be part of a customer data platform, or in big storage, big data platforms. And then some of these features that you can pre-calculate and are not too time sensitive, that would be added to that record, but not sort of. I just want to make clear, because it's so nicely top down. You don't have to sort of boil the ocean. I see a lot of organizations that think, hey, we're going to build our CDP or our data, our big data platform, and we're going to do that first because we need that to do analytics and we need to do decisioning on top of it. So that will have to wait. That's actually, although it sounds sort of common sense, but that's actually the wrong way of doing it. Because if you go from, well, it's not the wrong way of doing it, it's a very expensive way of doing it, right? Because you can use AI and machine learning to sort of figure out, hey, first of all, given that we're optimizing business outcomes, maybe the data that we have or can get relatively quickly will get us already 80% there, right? So you have like the funding and the business case to then iterate and make your data better, or increase the number of features that you would put in the feature store. All of these things are much better informed if you actually know what you have, rather than trying to be complete. And AI sort of, it's almost a side effect, but not really. AI and machine learning can report very accurately on, hey, this data works, with this kind of data, or there is a correlation between this and this, so you actually don't even need to store this, or certainly not, you don't have to make it available in real time. So from thousands and thousands and thousands of customer attributes, for instance, the predictive models may use a couple of hundred, maybe even tens, in some cases. And it's really good to know that. Otherwise, you will invest a lot of time and money in making the data perfect.
Are these next best action types of problems typically, at least the machine learning parts, supervised? Like, is there a requirement to label a lot of data?
It's usually really matched against, it's supervised because it's running against particular outcomes that we already know, right? So we are trying to predict, are you going to attrite, are you going to default on your loan, are you going to buy this product, are you going to make us, is the value of the relationship going to go up and down, and that's essentially what you learn about. So it's in that sense, it's supervised learning
It's
at a
supervised, but
very
your
high
labels
scale.
come from historical data as opposed
Except,
to needing to
yes, you don't
hand
have to do
label a particular
no,
transaction or
no end,
something.
no end labeling. No, no, no. This is all. Yeah, no, good question. Yeah, so that's all. This is all at a very large scale. I think part of this, it's only part, but part of this is trying to sort of industrialize this whole process, right? Because otherwise, it would just be daunting, right? So that's sort of the design phase is actually relatively easy. If you know what you're doing, you go from the outcomes and the rules and the data. It's like, and then you don't boil the ocean, but you start at maybe 80% of the value, which will be an astronomical figure usually, given the brands we work with at least. And then you can get from 80 to 85 to 90, maybe to 95, and maybe you don't even worry about the last 5%, because it may not even be worth squeezing the data for that last bit.
Yeah, maybe one last question on this. I think you spoke to this already from an explainability perspective and kind of the opacity of quote unquote fancy algorithms, which I took to mean deep learning. Um, Deep learning gets a lot of attention, but a lot of the bread and butter problems within enterprises are kind of these tabular data problems that it struggles with. I'm curious the types of models that you see. I'm assuming kind of a lot of classical tree based types of things. Are you also seeing places for deep learning within the this next best action problem?
Yeah, some, but as you say, because I get the question a lot, like, hey, we want to do deep learning, but again, it's often for deep learning sake, right? Because it is, first of all, it is opaque, so you have to be very careful in practice of what you let it predict. If this is the background color, okay, or the position of your billboard in the city, maybe, right? But whether you get like a mortgage or not, or be approved for a loan, there's no way any bank would apply a deep learning model to do that. But from our perspective, as I said before, we are really agnostic, and then allow. So if you, for instance, if we will work with a bank and the bank says we have like an incredible model to predict risk, right? Then you could actually. So we don't really care, except we allow them to apply sort of an AI policy. So transparency is a good one. There's more. Like bias and things like that, but that's part of sort of the AI policy. It's not our policy. That's not our place. But we allow these organizations to define an AI policy that we will automatically check against the algorithms, right? Which means that a deep learning model would not be compliant. So we would flag it as incompliant or not compliant if it is about the probability to take on a loan or recommend a loan. But we would probably approve it if it's about the position of a particular ad on the web page.
Got it. Got it. It's hard to visualize the user interface of a AI policy system. Although maybe it's similar to, it's another set of rules.
Yeah, it is like, well, it's more like the way we look at it is more like a filter. So you have like all of these models that you have in your library. So that's part of of model ops. It's like you have all of the models, and they get tagged by their explainability or the type of algorithm, and then we sort of see, well, this is allowed and this is part of the policy you just define, and say, hey, for this particular use case or this particular decision, we really have to insist on very transparent models like a decision tree or regression or just rules. Whereas here, go all out, right? So even if we don't really understand it, but we would flag before taking something into production. We would flag, the overall logic, which is, the heuristics plus the models as being out of compliance.
Now, transparency is just one aspect of responsible AI. What are some of the other ways that you're helping customers manage those challenges?
Yeah, well, so the way we define responsible AI, yeah, transparency is I think is clear, and we discussed. The other one is, I think, is also obvious, fairness. So is there a bias? But again, it's not a bias in the model, well, as well, but no bias or very acceptable bias, maybe, if there is anything acceptable about it. But in the model doesn't actually mean that your final decision will be biased, right? It's a very subtle combination of predictive insights with, like, for instance, eligibility or suitability or profitability rules may actually produce results you didn't expect, right? And that's what we, in that AI policy, test against. So you can have 100 models, you can have 1,000 different predictive models underneath all of the rules, and we check if the next best action distribution is actually fair, right? And I think that's the kind of thing, I think that's important. And then we have sort of softer things that we call it empathy in our responsible AI. It's maybe not even completely correct, because it's, you can be responsible without being empathetic. But we get, and I get, when I talk to executives, a lot of things like, well, we don't want to be a clinical brand that has this robot AI deciding what to do, and it's not warm enough, or it doesn't really reflect our brand values, and that's another aspect. So we also calculate sort of the softer elements, like, for instance, your level of empathy, your relevance. Like, are you, for instance, withholding relevant messages or actions to a particular, subgroup of your customer base? And if so, why is that? Is that, like, because it can be eligibility rule, like back to the car, selling the cars, or to teenagers, for instance. So in that case, that's okay that you're doing that. They may be interested, and the models may indicate they're interested, but you still can't do it. But it can be a lot more subtle, right? Maybe it's like a policy weight that you've set, or you put in competitive pressure, or you said, well, the profitability is so important. Like, for instance, we need to get this message out because we need to sell 10,000 of these, and we are completely spamming our customer base and nobody's interested. We would flag that kind of meta analysis to say that's not very empathetic, and you need to decide on what your brand is, and also what the cost is of doing those kind of things. And the last one, Sam, is around robustness. And this is a question I also get a lot, and that is like, if you have your predictive models, and they're static predictive models, so you've been building them, or your data science group has been building these models, and you execute them in real time, the model itself obviously doesn't need to change, and that's fine. So you can test it, you can simulate it, all of these things are fine. But if it's a self-learning model, especially if you have thousands of them, you want to make sure that none of them goes rogue, right? Like, hey, it's being exposed to real time, or real life, I should say, real life behavior, and suddenly it's doing weird things. And especially if you combine that with, like, maybe a deep learning algorithm, that can go haywire really quick. So that's another aspect that we make sure, like, okay, we are testing these self-learning models. Are they drifting? Are they drifting a little bit too quick? Is there a concern? And there's thousands of them, so you can't manually look at that. So you need to flag that for a data science or a governance body like the model office in a large organization, and say, hey, there's something weird going on. It still works. You're still fair, you're still making value, creating value, but this model is doing weird things, and you need to look at why that is, and we then help that discovery process.
Awesome. Awesome. Well, I know that in addition to customer engagement, one of the other things that you're excited about is your upcoming conference, PegaWorld. And before we wrap up, I wanted to give you a chance to share a bit about that. Is that a place where folks can come to learn more about the kinds of things we've been talking about?
Absolutely. So yeah, PegaWorld, all virtual, so everybody can sign up. It's free. Maybe the last time, or one of the last times we do it virtually only. But for now, it's virtual. Everybody can sign up. It is May 24th in the morning in the US, so it won't take up all of your day. And you will hear companies like for instance T-Mobile talk about much of this and their vision, and how they've been operating and productizing next best action. And then there's obviously breakdowns and deep dives. It's very interesting, and we'll talk about a lot of these kind of things. But you can also, as I said, hear it from the brands themselves.
Awesome. Well, Rob, great to see you once again, and thanks so much for joining the show and sharing a bit about what you've been up to recently, and digging into some more detail.
And thanks for having me, Sam, as always. Okay.
Thank you.
Bye-bye.